All right, so I want to revisit planets. Let me get a share screen going here. I mentioned that I abandoned the non-central approach because I couldn't think how to do collisions and coalescence. Um, but I realized I could use Unity's colliders uh, triggers as a way to detect and handle collisions between objects. Um, so again, in this situation, each planet has its own script that looks out into the world, finds all the tagged planets, the sun included, calculates the force it feels on them, and updates its own motion accordingly. So this is back to that non-central approach to things. So the script, this is the non-central, I call it unity physics situation. And again, we have an array for planets, their masses, the number. There is an energy calculation in here too, I believe, done by a separate entity. Um, um, One thing we need to do is get all the planets with a find game objects with tagged planets and go through and get their masses. We have to look it up on their own non-central unity physics script. And in the start function, uh, 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 I, I have to set things up. Again, that's done with some magic, and then start the Verilette coroutine that looks very much like it did in the original. We have to calculate force over mass, and here I'm now using a different version of Verilette's, uh, where I update position, calculate a new force over mass for that position, and use the average of those two accelerations to move my object forward. The force over mass, again, has to make sure we're not testing against ourselves because we are tagged planets, so we will be in the list. And here's that usual GM over R cubed for the total force. So the collisions are handled with on trigger enter. And if you remember, the on trigger event sends messages to both the object that uh, is collided with and to the object that collides with it. So each of these will be getting an on trigger event. First thing we need to do is make sure we've collided with a planet, otherwise we return. We get the non-central unity physics script off the other object that we've collided with. And we do this so that we can access the other's priority, and as well as mass and velocity that we need for conservation of momentum. Priority basically just decides which object is going to survive and which one will be destroyed. Lower numbers have higher priority, and the priority is assigned when they're spawned, usually just an integer number counting up to the object number. So we get the other's priority. If our priority is greater than the other's priority, we quit because the other one's going to destroy us anyway. I also decided to combine the colors of my objects. So we've got red and green objects. They're going to ultimately become yellow. And uh, uh, here we deal with the mass and the color lerping based on this factor as to which one is bigger than the other one. And that fractional amount determines how much we lerp the color into the new color. Then the conservation of momentum, essentially the same as what we've seen before, figuring up what the new velocity is and the new mass, and rescaling our planet uh, and uh, and instantiating a little collision explosion, and away we go. The spawning script. Um, one of the issues I ran into was that with the non-central script, we had exposed variables, and um, for this reason, it was not easy to set a game object that would be used to instantiate. And so instead, I did a little trick where if we have the prefab in a special resources folder, I can load directly from that resource folder. So my explosion here is not a exposed variable prefab game object, but instead is in a special directory, resources, and I'm loading it uh, when I instantiate it. The spawner script is somewhat like the others. The key here is getting a reasonable initial condition that has enough angular momentum so they don't all collapse into each other, and not too much angular momentum that they blow the whole system apart. And so this goes through and sets up these initial conditions. Again, with some physics that I'll let you read if you want to. We also use a center of mass kind of thing, and I have the star or the sun is the central body, and then there are all the other planets that we're instantiating. Um, I believe there's also uh, a script that keeps the target of the camera at the center of mass, and so it has to go through and uh, uh, figure out where this center of mass is. And this is also the thing that calculates the energy of the system. It moves the center of mass, and it also has to get the planets periodically, calculate energy, all exactly the same as what we saw before. Um, I found if I moved this every time step, it was too abrupt, and I didn't really want to do it every time step. I wanted to use, I'm only updating that energy and center of mass periodically. So I'm using a slurp to kind of make it move gradually from one position to another. So right off the bat, first we test out circular motion, whether two properly set up orbiting bodies stay in a nice circular orbit. They have a nice negative energy, and it's conserved pretty well. Uh, uh, Here they are. These are uniform masses. They're all exactly the same mass, so there's no central sun. I'm starting off with about 500, and you can see that the frame rate is abysmal. Later, I'll come back and show you how to fix that when we get to the job system. As these go on, they're colliding and we have fewer and fewer. I am calculating energy, but of course, energy is not being conserved in collision situations. Momentum is, but energy is not. As we get down around 200 or so, the frame rate starts to pick up, and we're left with just a handful of big, now kind of different colored planets. As we've combined the red, blue, and green objects, we're ending up with sort of whitish planets. And this is all very cool, and we can zoom and look around and so forth. I've got the solar system with asteroids again here. Uh, uh, there's Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. I didn't bother with Pluto, and all of these different asteroids, which, as I mentioned, seem to end up in the proper place in between Jupiter and Mars. And again, I don't know if that's an accident of the initial conditions that I set up, or if it's some fundamental orbital resonance that's going on. And incidentally, the scale of the planets and the asteroids is different, so that you can actually see the asteroids because they're so much smaller than the actual planets. And there's a solar system with an interloper and a colliding star. So have a look at that. And I'm going to stop sharing at this point, and end the recording, and I'll go back to, and I'll see you in class. Bye.